Hey guys, here is the review for our final exam. Let's jump into it. In the first question, we're asked to express this in simplest form. What you should notice right away is that we have this negative sign in front of the parentheses right here. When we have this negative sign, you should remember that we put this invisible one. There's that invisible one right there. So before we start combining and simplifying anything, we need to first distribute that negative one to all the terms in our second parentheses first. There is also an invisible one in front of our first parentheses right here. But 1 times any number or any term is going to be the same term. So we can just rewrite all the terms from the first parentheses as it is. So we would have 3x squared plus 4x minus 8. And then now I'm going to distribute this negative 1 to all the terms in the second parentheses. So -1 times -2 is going to be a positive 2x squared. -1 times positive 4x is just negative 4x. And -1 times positive 2 is -2. Notice that when you distribute a -1 to terms in a parentheses, all that happens is that the sign flips. So this -2x squared became a positive 2x squared, the positive 4x became a negative 4x, and this positive 2 became a negative 2. Now that I've distributed that, I can just go ahead and simplify by combining the like terms. So our first pair of like terms are 3x squared and 2x squared. So 3x squared plus 2x squared is just 5x squared. Then we have positive 4x minus 4x. So 4x minus 4x is just 0. So this is going to cancel out. We don't need to write 0x. We just leave it, we just cancel it out. That's it. And then our last pair of like terms are -8 minus 2. So -8 minus 2 is just going to be -10. So our final answer in simplest form is 5x squared minus 10, and that's it. All right, second question. Subtract 5x squared plus 2x minus 11 from 3x squared plus 8x minus 7. So the key word here is from. We're subtracting this expression from this expression. So we wouldn't write 5x squared plus 2x minus 11 minus this. We would actually take the second expression first and then subtract this expression. It's sort of backwards because we're subtracting this first expression from the second expression. So if we write that out, we would have 3x squared plus 8x minus 7, and then we're subtracting this first expression. So you want to put that first expression in a parentheses when we rewrite it. So we're going to rewrite it inside of a parentheses, 5x squared plus 2x minus 11. When we rewrite it in this parentheses, notice that we now have this subtraction sign in front of it. So right away, you should know that you're going to have to distribute that -1 to every term in the parentheses first before you can simplify. So let's go ahead and do that. Everything before that is going to stay the same. So I'm just going to rewrite all of these terms right here, 3x squared plus 8x minus 7. And then -1, sorry, this invisible -1. -1 times 5x squared is -5x squared. -1 times 2x is -2x. And -1 times -11 is +11. From here, all we have to do is combine all of the like terms. So our first pair of like terms are 3x squared minus 5x squared, which is just -2x x squared. Then we have 8x minus 2x, which is just 6x, positive 6x. And then our last pair of like terms is negative 7 plus 11, which is just going to be positive 4. And this is it. This is our final answer. We can combine anything else. So our final answer is negative 2x squared plus 6x plus 4. All right, cool. Our next question, what is the value of x in the equation 5 times 2x minus 4 over 3 plus 9 is equal to 14? So there are a couple of ways that we could do this question. First, the easiest way, since this is a multiple choice, would just be to substitute the answer choices for x into the equation using your calculator to see which one of the values would give you a 14, would give you 14. The second way is to use the solver on the calculator. And then the third way is just to solve it algebraically. So I'm going to show you how to use the solver on the calculator, and then I will show you how to do it algebraically. So if this is a multiple choice, if you have this multiple choice question, and we're using the calculator, you want to go to menu, and then you want to go to equal, and then we want to select F3 for solver. And then we're going to enter in that equation. So we're going to put the fraction, and we're going to have 5 parentheses 2x, sorry, 2x minus 4 over 3 plus 9 is equal to 14. And for that equal sign, we're going to hit shift and the little decimal button under number 2. All right, then we're going to hit enter 2 times, and we see that x is equal to 3.5. Right here, x is equal to 3.5. So that's our answer, which is choice 2. If we were to do this algebraically, if we were to solve this algebraically, our first step here would be to subtract this 9 from both sides. So I would subtract the 9 from both sides. This will cancel, and you'll be left with 5 times 2x minus 4 over 3 is equal to 5. Then our next step, we would want to get rid of this fraction so that we can solve easily. So to get rid of a fraction, we would multiply both sides by the denominator. So we would multiply both sides of this equation by 3. Then these two threes would cancel out, and we would be left with 5 times 2x minus 4 is equal to 15. From here, we can easily solve this equation. So all we have to do is distribute. 5 times 2x is 10x. 5 times negative 4 is negative 20 is equal to 15. Now we just need to move all the constants to one side. So I'm going to move this negative 20 over. I'll do inverse operation. So I'll add 20 to both sides. This will cancel, and we'll be left with 10x, I'm running out of space here, 10x is equal to 35. We know that our last step here would be to divide both sides by the number in front of x. So we divide both sides by 10. The 10s will cancel out, and we'll be left with x is equal to 3.5. 35 divided by 5 is 3.5. And that is our final answer. All right, next question. Solve the equation algebraically for x. All right, so first thing we want to do here is distribute. So we see that we have a negative 2.4 and we have a parentheses. So first thing we're going to do is distribute this negative 2.4. Negative 2.4 times x is negative 2.4x. Negative 2.4 times 1.4 is negative 3.36. Yep. And then we just rewrite everything else on the other side equal to 6.8x minus 22.68. From here, we need to move all the x terms to the left side of the equation and all the constants or the numbers to the right side of the equation. So I need to bring this 6.8x over to the left side. So I'm going to do the opposite. Since the 6.8 is positive, I'm going to subtract 6.8x from both sides. This will cancel, and negative 2.4 minus 6.8 is negative 9.2x. I'm going to bring down my negative 3.36, and that is equal to negative 22.68. Now I just need to move this negative 3.36 to the right side. So again, I will do the opposite, right? I will do inverse operation. So since this is negative 3.36, I'm going to add 3.36 to both sides. This will cancel, and we'll have negative 9.2x is equal to negative 19.32. Last step here to solve for x is to divide both sides by the number in front of x. So we're going to divide both sides by that negative 9.2. The negative 9.2s will cancel, and we'll see that x is equal to positive 2.1. And all of these addition and subtraction and multiplication of decimals, make sure you put those values into your calculator to be sure. All right, that's it. Next question. All right. Jean's scores on 5 mathematics tests were 98, 97, 99, 98, and 96. Her scores on 5 English tests were 78, 84, 95, 72, and 79. Which statement is true about the standard deviations for the scores? So here we need to compare the standard deviation for her math scores and her English scores. So to find out the standard deviation, we can use our calculator. We're going to go to Menu, Stat, and in list one, we're going to enter the math test scores. So 98, 97, 99, 98, and 96. And then we're going to hit F2, F1, and if you look at that little sign, that little symbol that looks like an OX, it's actually called sigma x. That's their standard deviation. So the standard deviation for her math scores, I'm gonna write here, I'm gonna write it on the side. Math SD or math sigma is equal to 1.019. I'm gonna just take 3 decimal places. Then we're gonna hit exit, clear out that table, clear out that column, and then we're gonna put in their English scores. So 78, 84, 95, 72, and 79. Again, we're gonna hit F1, and our standard deviation here, the sigma x, is 7.709. So English sigma is equal to 7.709. Great. So if we compare these two standard deviations, um, choice one says the standard deviation for English is greater than the standard deviation for math, right? And that's true. Our standard deviation for English is 7.709, and whereas math is just 1.019. So we can see that the standard deviation for English is greater than math, right? And then the standard deviation for the math, choice two says the standard deviation for the math scores is greater than that of English. Obviously, that's not true. Standard deviation for both sets of scores is equal. That's again not true. And then more information is needed to determine a relationship. No, because we actually did find the standard deviation. So here our answer would be choice one. And if you were not able, like if you did not have a calculator to calculate the standard deviation, you can actually figure this out just by looking at her scores. So the standard deviation tells you how far apart the scores are from the mean. So if you just look at her scores, right? If we just look at what she got for math, it's 98, 97, 99, 98, and then a 96. These scores are all in the 90s and they're pretty much close to each other, right? 98 and 97, right? That's just 1 point away from each other. So these are very close to each other. So we would expect that the standard deviation would be very small because there is not a large gap between each score. However, if you look at her English scores, right, we went from 78 to 84, all the way to 95, and then back down to 72. Right. So there's more gaps between her English scores, right? It's spread out more. So we would expect the standard deviation for her English scores to be higher. So without calculating what the standard deviation is, you could have seen that choice one would have been the answer because the standard deviation for her English scores is greater because the scores are spread out. All right, next question. The box plot below summarizes the data for the amount of snowfall in inches during the winter of 2021 for 12 locations in Western New York. What is the interquartile range? So remember, interquartile range, the formula is Q3 minus Q1. So on our box plot, we know that this is our min. This is Q1, Q2. Q2 is also the median. This is Q3, and this last part is our max. So if we're computing the IQR, Q3 here is going to be 110, and Q1 is 60. 110 minus 60 is just 50. So our IQR here is equal to 50, which is choice two. And that's all there is for that question. All right, next question is a linear regression question. The owner of an ice cream stand kept track of the number of ice cream cones that were sold each day for the first week in June. She compared the ice cream sales to the average daily temperature. The data is shown in the table below. We are asked to state the linear regression equation for these data, rounding all values to the nearest hundred. So to do this, to find the linear regression equation, we're going to go to Menu, Stat, clear out our table, and then we are going to enter the X values, the average daily temperature values in list one. So we're going to enter 72, 75, 81, 78, 77, 76, and 80. And then in list two, we're going to enter all the Y values, the daily ice cream cone sales. So 126, 183, 263, 229, 200, 185, and 249. Then we're going to hit F3 for regression, F1 for X, and then our linear regression equation, we're going to use the AX plus B. So we're going to hit F1. Perfect. So the linear regression equation, we know it's y equals AX plus B. And our calculator gives us the A value and the B value. So for A, we have 15.125. A is equal to 15.125, and B is equal to negative 959.625. We're going to substitute these values into our equation, rounding it to the nearest hundred. So if I'm rounding 15.125 to the nearest hundreds, I need to have two numbers after the decimal point. So I'm going to mark my two numbers here. And then to decide if I'm going to round up, I'm going to look at the third number. So I'm looking at this 5. If it's 5 or more, we know that the 2 is going to go up by 1. So because this is a 5, our A is going to round to 15.13. So we will have y is equal to 15.13x. And then our b value, negative 959.625. Again, we're rounding to the nearest hundred, so I need two places after the decimal point. I'm going to look at the third number. Since that's a 5, I know that this 2 is going to go up by 1. So in my equation, I'll have minus 959.63. And that's it. That's my linear regression equation. Next, we're asked to state the correlation coefficient to the nearest hundred. So the correlation coefficient is our R value. Looking at our calculator screen, we see that R is equal to 0.99, and that's rounded to the nearest hundred. Lastly, we're asked to state what the correlation coefficient indicates about the linear fit of the data. So since R is equal to 0.99, it's positive and it's really close to 1. We know that that is a strong positive correlation, right? And then we want to say what it indicates about the data. So we have to say that there is a strong, I'm going to write it out at the bottom here, strong positive correlation between the average daily temperature and the daily ice cream cone sales. And this makes sense, right? There would be a strong positive correlation because as temperature increases, ice cream sales increases, right? As the weather gets warmer, people tend to buy ice cream a little bit more. All right, and that's all there is for the linear regression question. Next, we have when solving for p squared plus 5, I apologize, this font is really small, but the question says when solving for p squared plus 5 is equal to 8p minus 7, Kate wrote p squared plus 12 equals 8p. The property she used is what? So we're trying to find out how did she go from this equation to this equation? What did she do? So what changed was this 5 turned to a 12, and then she got rid of the negative 7 over here. So what Kate did, she actually added 7 to both sides because 5 plus 7 is 12, right? And then if we add 7 to both sides here, this is going to cancel out, which is why she does not have that 7 in the second equation when she rewrote it. So if Kate added 7 to both sides of the equation, then she used the addition property of equality, which is basically adding a value to both sides of the equation. So our answer choice here is 4. Next, we have when solving for x squared plus 6x equals -8 for x, a student wrote x squared plus 6x plus 8 equals 0 as their first step. What property justifies this step? So, how did we go from this equation to this equation? Well, what happened was this -8 got moved over to the left side of the equal sign and it turned to a 0 over here. So what happened, if you look at it, this -8 was added to both sides of the equations. When you do that, the -8 would cancel on the right side and it would be added on to the left side. So we would have x squared plus 6x plus 8. So if we added 8 to both sides of an equation, our property that we used would be the addition property of equality as well, because we're adding a value to both sides of the equation to keep it balanced. All right, cool. That's all there is for that question. That's all there is for the first page. All right, next half. Solve the inequality for y. So here we're just solving the inequality for y. I see parentheses, so I know my first step is going to be to distribute. 5 times 2 is 10. 5 times -y is -5y, and that's greater than -11y minus 8. From here, my next step is to move all the y terms to the left side of the equation and move all the numbers, the constants, over to the right side of the equation. So I want to bring this -11y over to the left side. So I'm going to do the opposite. Since it's -11y is being subtracted, I'm going to add 11y to both sides. This will cancel, and we will have 10 plus 6y is greater than -8. My next step is to move the 10 over to the right side of the equation. So I'm going to do the opposite. I'm going to subtract 10 from both sides of the equation. 10 minus 10 will cancel out, and I'll be left with 6y is greater than -18. Last step here to solve for y is to divide both sides by the number in front of y. So divide both sides by 6. Those will cancel out, and you'll be left with y is greater than -3. And that's it. We solved for y. All right, next question. Graph the system of inequalities on the set of axes below. So I'm just going to rewrite this a little bit better so we could see it. The first inequality is y is greater than 3x minus 4. And the second inequality, this one, is x plus 2y is less than or equal to 6. All right, so let's graph the first inequality. Let's graph y is greater than 3x minus 4. So we know that we always start on the y-axis, and we always start at the number without the x, right, or y-intercept. So our first point is going to go on -4, and our slope is 3. So we know that we're going to go up 3, right 1. If we don't have a fraction, this is always over an invisible 1. So we're going up 3, right 1. This is a horrible arrow. All right, there we go. Okay, so up 3, right 1, up 3, right 1, up 3, right 1, up 3, right 1. And if we go in the opposite direction, we're going to go down 3, left 1, down 3, left 1. Now, since we have y is greater than, right? We look at the sign to decide what kind of line we're going to do. Are we going to do a solid line or are we going to do a dashed line? When we have a greater than or a less than sign, we're gonna do a dashed line. I should write that down. Let me write that down. So when we have a greater than or less than, we do a dashed line. So for my points here, I'm going to make a dashed line going through my points. Don't forget the arrows at the ends of the line. And now in my inequality, since I have y is greater than, I need to decide which way I'm going to shade. So if my inequality is greater than and my values would be increasing, I know that I would need to shade above, right? Greater than is shading above, less than is shading below. So if I'm to shade above this line, I'm going to shade this part of the graph. And you want to shade above, where did my shading go? You want to shade above the entire line. So we're going to shade this entire part of the graph, everywhere above this line. All right, not too bad. And then remember, we always want to label one of our lines. So we're going to label this y is greater than 3x minus 4. Lovely. Now we need to graph the second line. But notice that it's not in slope-intercept form, right? So we need to put this inequality in slope-intercept form before we can graph it. So we need to solve for x. So all we need to do here to solve for x, our first step would be to get this 2y by itself. So we subtract the x term from both sides. So we subtract x on both sides. X minus x will cancel. And then we'll be left with 2y is less than or equal to negative x plus 6. Last step here is to divide both sides by the number in front of y. So we're going to divide both sides by 2. The 2's will cancel from in front of the y, and we'll be left with y is less than or equal to negative 1 over 2x, so a negative half x, plus 3. Right? So this part right here, we know that there's an invisible 1 in front of the x, right? So we rewrite this as negative 1 over 2x. And then 6 divided by 2 is just 3. Okay, now that it's in slope-intercept form, we can go ahead and graph that. So we would start at 3 on the y-axis, and then our slope is negative 1 over 2. So we would go down 1, right 2. Down 1, right 2. And if we were to go in the opposite direction, we would go up 1, left 2. Up 1, left 2. Now we need to decide, are we going to have a dashed line or a solid line? So we're going to look at the inequality sign. Here, it's less than or equal to. Whenever it's less than or equal to or greater than or equal to, because it's equal to, we're going to have a solid line. So I should also write that down. Less than or equal to or greater than or equal to is going to be a solid line. So I'm going to make a nice solid line. Hopefully I don't butcher this line. Yay, that looks perfect. Okay, so we make a solid line through our points, put the arrows on the end, and now we need to decide which way are we going to shade. So our sign is less than or equal to. So if it's less than, we're going to shade below our line. So I'm going to shade everywhere below this line. Be careful when you're shading not to just stop right here, right? You want to shade everywhere below the line. And this is a much horrible shading than the other one, but it will do. All right, perfect. So now we need to decide where to put our solution set, right? So right here it says label the solution set S. So if you notice, right, when we shaded, this region of our graph got shaded twice. This is our double shaded region, right? We first shaded above our dashed line, and then we shaded below our solid line, right? So this portion of our graph right here got shaded twice. This is our double shaded region. So we would draw our S representing our solution set in this region, just like that. So I'm going to put a big giant S right here, right? And this represents our solution set is in this region. Lastly, the question asks, is the point 2, 2 a solution to the system? So the point 2 comma 2 is right up here. That's this point right here. Is this point a solution to the system? Well, notice that the point is the intersection point. However, even though it's the intersection point, it lies on a dashed line. And remember that points that are on a dashed line are not solutions to the inequality. So we would say, no, this point is not a solution because it lies on the dashed line. Okay, I'm running out of space. No, because the point 2 comma 2 lies on a dash line. All right, and that's all there is to graphing that system of inequalities. So just a couple of things to remember. Make sure you pay attention to your inequality sign to decide if you're going to have a solid or dashed line. Make sure you label one of your lines. Make sure there are arrows on the ends of your lines. And then make sure you look at your inequality sign to decide which way to shade. And then lastly, put a S in the double shaded region of your graph to represent the solution set. All right, next question. We're almost to the end. Courtney went to a coffee shop to purchase lattes and donuts for her friends. One day she spent a total of 15.50 on 4 lattes and 2 donuts. The next day she spent a total of 18.10 on 3 lattes and 5 donuts. All prices included tax. If X represents the cost of one latte and Y represents the cost of one donut, write a system of equations that can be used to model this situation. So if X is the cost of one latte and Y is the cost of one donut, we want to use that to write the equation for what Courtney purchased. So in this first line right here, she spent a total of 15.50 on 4 lattes and 2 donuts. So this part right here is going to help us write our first equation. So we know that X is representing latte. So if Courtney bought 4 lattes, then we would write that as 4X. And if she purchased 2 donuts, then we would write that as 2Y. And she spent a total of $15.50. So 4X plus 2Y is equal to 15.50. And that's their first equation. Next, they told us that she spent a total of 18.10 on 3 lattes and 5 donuts. So if we were to write that as an equation, 3 lattes would be 3X and 5 donuts would be 5Y. So 3X plus 5Y is equal to 18.10. And that's it. That's our system of equations. Next, Courtney thinks that one latte costs 2.75 and one donut costs 2.25. Is Courtney correct? And we're asked to justify our answer. So for this part, we need to algebraically show that if 275 and 225 would satisfy both of these equations, right? When we substitute 275 and 225, would we get the total that Courtney actually paid? So we're going to do that. So we're going to take our first equation, 4x, and we're going to substitute the price 275 for x because Courtney thinks that the latte is 275 plus 2y, and we're going to substitute 225 for y, and all of that is equal to 1550, right? This part of the equation, you can put it into the calculator, right? You can put that entire expression into the calculator. So if you just go back to menu, right, we have 4 parentheses 275 plus 2 times 225, and that's equal to 15.5, right? So this entire part right here is 15.5, and that's equal to 15.50. So 15.5 and 15.50 is the same thing, right? So this this price, 275 and 225, does work for the first equation, right? So far she's right. But we also need to make sure that it works for both equations. So we still need to substitute these values into our second equation. So doing that, we would have, I'm going to do it right on the side here. So we're substituting 275 and 225 into the second equation, 3x plus 5y. So 3 times 275 plus 5 times 225 is equal to 1810, right? So again, you can put this entire part into the calculator, or you can do it step by step. So let's just put the entire thing into the calculator. 3 times 275 plus 5 times 225. That's equal to 19.5, so $19.50. Where's my pencil? So 19.5, bring down the 1810. Obviously, 19.5 is not equal to 1810. So this cost, 275 and 225, does not work for the second equation. So Courtney is not correct, right? And they asked us to justify our answer, right? So we would say that she's not correct because 275 and 225 does not satisfy both of the equations. All right, cool. Lastly, the last part, we are asked to use the equations to algebraically determine the exact cost of one latte and one donut. So here we need to use either substitution or elimination to algebraically solve for the cost of the donut and latte. So I'm gonna use elimination here. You could also use substitution. Either one will work. But I'm gonna use elimination here because I think it would be a little bit faster. And also I wanna show you more practice on elimination. So we would first rewrite our two equations, 4x plus 2y is equal to 1550, and 3x plus 5y is equal to 1810. Okay, so for elimination, we need to have a pair of opposites so that we can cancel when we add. Here, we don't have any opposite terms, so I need to make them opposites. So we'll multiply the top equation by the coefficient from the bottom. So we'll multiply the top by -3, and then we'll multiply the bottom by 4. So all that happened is I took the 3 from my bottom equation and I'm multiplying the top by that 3, and we make one of them negative so that we can have opposites. And then I took the coefficient 4 from my top equation and I'm multiplying the bottom equation by that. Now we're just going to distribute and simplify. So -3, let me just organize this a little bit so it's not very messy. -3 times 4x is -12x. -3 times 2y is -6y. And -3 times 15.50 is -46.5. Remember, when you're distributing, you distribute to all the terms in the parentheses, even the term, even that constant, that number after the equal sign. Okay, and then 4 times 3 is 12. 4 times 3x is 12x. 4 times 5y is 20y. And 4 times 1810 is 72.4. Great. Now, if you notice, we have opposites, right, in our two equations. We have -12x on top, +12x on the bottom. So if we were to add these two equations, those would cancel out, right? Those would eliminate, which is what we want, and then we can solve for y. So we're going to continue to do that. I'm just going to rewrite them on the side here. So -12x minus 6y is equal to -46.5, and 12x plus 20y is equal to 72.4. Now we're just going to add both equations together. -12x plus 12x is going to eliminate. -6y plus 20y is just going to be 14y. And -46.5 plus 72.4 is 25.9. The last step here is to divide both sides by the coefficient of y, to divide both sides by 14. After you do that, you're going to see that y is equal to 1.85. So this is telling us that the cost of one donut is $1.85. Now we need to go back and solve for x. So we know what y is. We're going to pick one of the equations, one of our original equations. So we can just go with the first one right here. 4x plus 2y is equal to 1550. I'm just going to write it on the side again over here. So 4x plus 2, and we're going to substitute 185 for y. And that's equal to 15.50. All right, next we just simplify. So 4x plus 2 times 185 is 3.7. So plus 3.7 is equal to 15.50. Next step, we need to get the 4x by itself. So we're going to move the 3.7 over to the other side. So we're going to do the opposite. Since it's plus 3.7, we're going to subtract 3.7 from both sides. This will cancel, and you'll be left with 4x is equal to 11.8. Again, our last step is to divide both sides by that number in front of x. So we divide both sides by 4, and you'll see that x is equal to 2.95. So right here, x equals 2.95. And that tells us that the cost of one latte is $2.95. Okay, perfect. Last two questions. We're almost there. This one's really hard to see. I'm so sorry. All right. A middle school conducted a survey of students to determine if they spent more time playing games or watching videos on their tablets. The results are shown in the table below. Question says, of the students who spent more time playing games on their tablets, approximately what percent were boys? So right away, they're telling us of the students who spend more time playing games on their tablets. So we're looking at this column right here. We're looking at the column of students who play games. And then next they're asking us, of those students, what percent were boys? So if we're looking at the total number of students that are playing video games, that would be 192, right? That would be our denominator in our work, right? So that 192 goes on the bottom. Our total always goes on the bottom. And they want to know what percent were boys. So in this column of playing games, there are 138 boys, right? So that number would go in our numerator on top. Now we just need to calculate this. 138 divided by 192. You can do this on your calculator. 138 divided by 192 is equal to 0.71875, right? And we need to convert that to a percent. So when you have a decimal, sorry, and you want to convert it to a percent, all you need to do is multiply the decimal by 100, right? So if you do that, you're going to see that it's just going to be 71.8%. And if we round that up to a whole number, it would be 72%. So this is approximately 72%, which is choice 3. So all you have to do for this question, just to recap, they asked us of the students who spent more time playing video games. So you first identify that column that you're being asked to look at, which is playing video games. Identify the total population in there, which is 192, right? The total population becomes your denominator, and then we're asked what percent were boys. So in this column of playing games, there is 138 boys. That goes on top as our numerator. You want to divide those to get your decimal, and then convert that back to a percent. And that is all there is to that question. Last question. A survey was given to 180 cell phone owners about the brand of phone they own. The results showed that 59 adults own brand B and 32 teenagers own brand A. Of the people surveyed, 40% own brand A. Complete the two-way frequency table below. So we can start step by step with filling out whatever information was given to us. In the first sentence, we are told that the survey was given to 180 cell phone owners. So that tells us that the total population or the total number of people that were in the survey is 180. So that value would go in the total column of our table. So that 180 would go right here, right? And this is representing the total number of individuals in this survey. Next, we are told that the results showed that 59 adults own brand B. So we would go to the column of brand B, and we know that there were 59 adults that own brand B. So brand B and adults, that would be this column right here. So we would throw our 59 into this little section right here. And then we're told that 32 of the teenagers own brand A. So again, we would go to the brand A column, look for teenagers, and then we would stick that 32 right in there. So 32 teenagers own brand A. Next, it says, of all the people surveyed, of all the people surveyed, 40% own brand A. So 40% of all the people surveyed. So to calculate that, we would first need to convert 40% to a decimal, right? So to do that, you know that your decimal point is all the way in the end here. You just move it 2 spaces back. So our decimal is 0.40. So we would do 0.40 times 100. Sorry, 0.40 times 180, and then we would convert that to a percent. Sorry, we would convert that to the whole number. So 0.40 times 180, put that in your calculator, and you would see that I think it's going to be around 70 something, 72. 0.40 times 180. Yep, it's 72. So that's the number of individuals that were owning brand A. Yeah, of all the people surveyed, 40% own brand A. So therefore, 72 people, 72 persons, what am I saying? 72 persons own brand A. Now that we've filled in all of the information that was given to us, we can use that to calculate the missing information in the table. So that's very easy. If we're missing a spot, right, we take the total and subtract what's given to us. So if we're trying to find this little column right here, that little piece, we would do 180 minus 72, right? Because we have this entire row right here. So we would do 180 minus 72, which is 108. Right? To find the missing piece between brand B for teenagers, you would just take the total and subtract what you already have. So 108 minus 59, which is 49. And now to find the total for the teenagers, you just add across. So 32 plus 49, which is 81. So there is a total of 81 teenagers. And if we're finding the number of adults in brand A, you will take the total 72 minus the 32 teenagers, and you're going to get 40. And then lastly, to find the total adults, you would just add the 40 plus 59, which would be 99. And that's it. That's all there is to filling out this table, right? So what you want to do is start by filling in whatever information is given to you, and then use the totals to subtract what's given to find the missing information. All right, and that's all there is to it. That's the last question. I hope this was helpful. Um, yeah, I hope this was helpful. Make sure you guys review for your final. Bye.